So today, we talked about greatest common factor and least common multiple. We did a little bit of review on what a factor is. We talked about a factor being a counting number when multiplied by another counting number equals n, where any number can be n. So we talk about counting numbers because when you count, you go from 1, 2, 3. You don't go 0. You don't count from negative numbers, and you don't count decimals. So a counting number, when multiplied by another counting number equals n. So we want to talk about common factors. So we'll take two numbers. We'll take 18 and 30. And in the past, you learned about that you could, you find the factors of 18, 1, 2, 3, 6, 9, and 18. And you find the factors of 30, 1, 2, 3, 5, 6, 10, 15, and 30. And you look at them and you say, okay, well, I see that 1 is the same, 2 is the same, 3 is the same, 6 is the same, and none of the others are the same. So I know that 6 is the greatest common factor. And what I showed you today, or what I want to show you, is that there's a different way to do it. And we can work with these same numbers, 18 and 30. But it will be better to work. It would be better when you can work when you find having to find the greatest common factors of larger numbers. So let me just erase all of this. So one way that you can do this is by finding the prime factorization of both of these numbers. The best way to find a prime factorization is to do a factor tree. So you can do a factor tree of 18. We break it into two factors of 18, and these can be any two factors, say 9 and 2. And I know that 2 is a prime number. 9 is not a prime number. 9 can be broken up into 3 times 3. So the prime factorization of 18 is 2 times 3 times 3. And 30, you can treat the same way. So two factors of 30, I can use 5 times 6 times. So 5 is a prime number. 6 is not a prime number. 6 can be broken into 2 times 3. So the prime factorization of 30 is 2 times 3 times 5. And so what I do here is I notice that these numbers, 18 and 30, they share a common prime factor of 2, and they share a common prime factor of 3. And all I need to do is multiply those two numbers. So they share a 2 and they share a 3. 2 times 3, 6. 6 is the greatest common factor. Now, or GCF. So you can do this with any two numbers. Numbers that you might have trouble remembering all of the factors of. So we could try again, and we could do any two numbers you would like. We can do, say, 56 and 32. So we can break these down the same way. So 56, we could do 2 times 28. 2 is a prime number. 28 can be broken into 4, 7. It's 2 and 2 in prime. So the prime factorization of 56 is 2 times 2 times 2 times 7. And 32, the prime factorization, do 8 times 4, which is 2 times 2. This is 4 times 2. Let's move this out of the way. Which is, oops, 2, 2. So the prime factorization of 32 is 2 times 2 times 2, 2 times 2 times 2 times 2 times 2. 5 2s. And then we look and see which of the factors they share. So you can see that they share 1 pair of 2s, 2 pair of 2s, 3 pairs of 2s. So the greatest common factor would be the product of 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So the greatest common factor of 56 and 32 is